electrophilic addition to alkenes, that's to double bonds. The first example here is addition of hydronium ion. Hydronium ion is H3O+. That basically means water with an acid. And the acid is shown by using H+, hydrogen ions, which could come from any acid. It could be phosphoric acid, hydrochloric acid, or hydrobromic acid. So when you put water and any acid together, you end up adding H and OH across the double bond following Markovnikov fashion. Markovnikov addition means that this hydrogen will add to the carbon with the most hydrogen. So this position 1 has the most hydrogen, so you end up with a hydrogen there. And then the OH will add to the carbon with the least hydrogen, in this case no hydrogen, and therefore you end up with the OH at that position. The next reaction is addition of HX across the double bond, where X is a halogen, which could be chlorine, bromine, iodine. So you end up adding H and X across the double bond following Markovnikov fashion, and the result is alkyl halides. Just like we saw before, hydrogen will add to the carbon with the most hydrogen. So this carbon here has the most hydrogen, so you end up adding hydrogen there. And then the halogen will add to the next carbon, which has less hydrogen. So you end up with a halogen there, the X there. Remember, HX can be HCl or HBr. The next reaction is addition of HX across the double bond, but now anti-Markovnikov. For that, you need a peroxide. So if you see HX with peroxides, the result is addition of H and X across the double bond in anti-Markovnikov fashion. That means hydrogen will add to the carbon with the least hydrogen. So this carbon here, so you end up with a hydrogen added there. And then the X group, the halogen, will add to the carbon with the most hydrogen. So you end up with the X group there. Number 3, addition of HO and X. You add HO and X following Markovnikov fashion, and this reaction requires X2. So X2 can be Cl2 or Br2, so chlorine or bromine. All reactions that involve bromine or chlorine are anti-addition. That means that if you're adding across this carbon, one group will come out. So one of the X will go out, and then the other X will go in. So we say anti-addition, and it results in what's called trans product. In this case, if you have X2 with water, then you end up adding X and OH across the double bond, and it's going to be an anti-addition giving a trans product. So in this case, X adds to the carbon with the least hydrogen. Remember, we want to show a trans product, so X adds there. And if X adds with the X group going into the plane, then the OH will add with the OH group coming out of the plane, so that you end up with a trans product. Next reaction is addition of X and X across the double bond, where we're using X2, where X2 can be bromine or chlorine. And again, that's an anti-addition resulting in a trans product. So you end up with one X group going in and the other X group coming out. I have a short video on the mechanism for this reaction. You can review it, where we're using bromine. Number 5, dihydroxylation. That's where we're adding OH and OH groups across the double bond. Addition of OH and OH group using osmium tetroxide. So you see OSO4. It will end up adding the OH and OH in a syn fashion. So it's a syn addition. That means both OH groups adds from the same side. So you end up with both OH groups coming out or both OH groups going in. And this product is cis. So the OH groups positions are cis to each other. So that's syn addition resulting in cis product. Number 6, reaction with carbenes. Carbenes will react with double bonds to form cyclopropanes. So if that was the alkene, and then the carbene actually introduces one carbon, and you end up with a three-membered ring becoming a cyclopropane. So the first example is where we are adding CH2 group. Now remember, carbene actually behaves as both a nucleophile and an electrophile. And sometimes carbene is represented like this, CH2 with 2 electrons. So what happens when you add a carbene? So for example here, if you use CH2I2 with zinc copper amalgam, so zinc copper, you end up adding CH2 across the double bond, and it's going to add from the same side, so you end up with a CH2 added across the double bond. So H and H. Another example is where you end up adding a CX2. In this case, X is Br, so CBr2 across the double bond. An example of that is when you use CHBr3 with a base like potassium hydroxide. You end up forming a carbene. This carbene shown here, and the resulting product is a cyclopropane, but now you add CBr2 across the double bond. So you end up with this product, C, Br, and Br. The next reaction is hydrogenation, where you're adding H and H across the double bond, and that one will reduce alkenes to become alkane. So it just becomes a single bond. So in this case, we're using hydrogen gas, H2, with palladium metal. So either use palladium metal catalyst, or hydrogen with nickel metal catalyst, or hydrogen with platinum metal catalyst. And the result is that you end up adding hydrogen and hydrogen across the double bond. It's a syn addition, giving alkane. So that's an alkane. Stay tuned for the next series on preparation of alkenes and reaction of alkenes.